Okay, welcome to day 2. Today we're going to focus on finding the volume of a cylinder. Now, there's going to be a formula for that, but before we get to it, I'll explain to you where the formula comes from and all of that. This is aim number 84, so you should be copying this down right into your math notebook. For the homework, I'll post what the homework's going to be online. Either it'll probably be out of the green packet, but if I decide to post a worksheet, I'll post it there as well. Okay? All right, hit pause if you need to finish copying down your aim. I'm going to move on to the next screen, which is your do now. So we're going to treat each video like a regular class. So there is your do now. Let me pause so you can read it. It says the volume of a water in the rectangular fish tank is 2,760 cubic inches. How much more water could fit into that tank? Okay, so based on the fact that the tank is obviously bigger than the amount of water that's in there, I know that I'm first going to find the volume of the tank and then figure out how much is that volume compared to the volume of water that's in there. So volume equals length times width times height. Okay. Again, what you call the length and the width and the height really doesn't matter. I'm going to call the length 16, the height 24, and the width 24 and the height 18. Now I'm going to go ahead and get my calculator out, find out what that volume comes out to be. 16 times 24 times 18 is 6,912 inches cubed. Does that seem right? 16 times 24 times 18. Just try that again. Yeah, that's it. The reason why I'm thinking that is because it seems like, I guess I just can't go by the picture. It says the volume of water in there is 2,760. And that would be actually less than half of the volume of the tank, but it is what it is. Let's just keep going with the problem. So how much volume or how much more water can fit in there? So we want to find the volume of that space there. So we're going to take the volume of the tank, subtract the volume of the water, and when I do that, I end up with, I got to get my calculator out, 6912 minus 27660 equals 4,152 cubic inches. Okay, that's the volume of the water that can still fit in there. Now, I know the picture doesn't fit that. I don't know what I was thinking when I came up with these numbers, but anyway, 4,152 should be the amount of water that can still fit into that tank. All right, hit pause. You need to take down some notes, and then we'll move into the next slide. Okay, let's recall from yesterday that when we were finding the volume of the prism, it was really the area of the base piece. The base is the two pieces that are opposite of each other and sort of parallel. So since the base of this, the area of the base of the top is a rectangle, it's length times width. The area of the base is length times width, and then you multiply by the height. So the same thing is going to happen today, except that our shape will not be a rectangle on top. Since we're dealing with a cylinder, it'll be a circle. Okay, so let's look at, let me get rid of my drawings there. Let's take a look at a cylinder. Cylinder is that three-dimensional shape, but the top of a cylinder now is a circular piece and a circular piece on the bottom. So when we go to find the volume of this thing, it can't be length times width times height because the area of that top piece is not length times width. Okay. So the area of a cylinder, I want you to think of it this way. That cylindrical top has a radius to it, which you see down here. That's the distance from the center of the circle to the outside. The cylinder itself has a height to it. So down here where you see this formula for volume, pi r squared h, what that's coming from is the area of the base, which is a circle, pi r squared, times the height of that thing. So the area of this top piece is a circle. The area of a circle is pi r squared. So that's where this part of the formula is coming from. Then you just multiply it by the height of the cylinder, and that's the volume of a cylinder. Okay, it just keeps the same theory of it's the area of the base piece times the height of the whole thing. Okay, so there's your circles. Radius is there, pi r squared times the height of the whole cylinder. All right, let's practice one. Get your calculators ready. It'll be a pretty straightforward, pretty standard one. Take a look at the following. I gotta keep remembering to get rid of my writing. Okay, a storage container in the shape of a right cylindrical cylinder shown in the diagram below. What is the volume of this container to the nearest hundredth? Now, to the right, you already see all my answers all played out. But if you notice, when I looked at that picture, I could see that the height of that cylinder was 10 inches. That's where this piece is coming from here. To get the area of the circle on top, I do pi r squared. But the question some of you might be asking is, why did I plug in 4 there, not 8? Well, the reason that I plugged in 4 is because 8 is actually the diameter of this cylinder. The diameter is the distance all the way across. So if the diameter is 8, the radius is half that, it's 4. So that's why I use 4. Now, 4 squared is 16. 16 times 10 is 160. So that's where the 160 came from. This would be me leaving it in terms of pi. So if someone said leave your answer in terms of pi, I'd actually stop right here. I don't. I said, what is the volume of this container to the nearest hundredth? So that's the second, excuse me, that's the second decimal spot. So take 160, multiply it by pi, use the pi button in your calculator so that you're as accurate as you can be. And when you do that, you end up with 502.65. Now, what I didn't tell you, this was actually a multiple choice question. There's the answer, 502.65 inches cubed. All right, pause it if you need to write down some things. We're going to move right into the next question. Okay, determine the volume of this cylinder below in terms of pi. So this time we're not going to get a decimal answer for this thing. We're going to leave it in terms of pi. So I got to go to my formula. Volume equals, well, it's a cylinder, so pi r squared times h. Pi times, looks like the radius is 10. Gives us this time. There's no trick to that. The height is 21. Pi times 100 times 21, excuse me. Can't read my own handwriting. It's getting a little sloppy here. 100 times 21 is 2100 pi. So when I leave it in terms of pi, and you can put feet cubed if you want to, I do not multiply by pi. I leave it as it is. So there's the volume of that cylinder. Okay, last one of the day. Here we go. It's a hard one. I want you to hit pause, try it on your own, then we'll come back and talk about the answer. Okay, in the accompanying diagram, a rectangular container with the dimensions of 10 by 15 by 20 is to be filled up with water using a cup whose radius is 2 inches and whose height is 5 inches. It's the maximum number of cups needed to fill that tank. Now, this sort of reminds me of the question we did yesterday with money bags. The difference was they told us how much each bottle of water could hold, so we didn't have to figure that out. We're going to have to figure out both of the volumes in this one and then do some work from there. So let's start first with the tank. This tank here is volume equals length times width times height because it's a rectangular prism. So 15 times 20 times 10. So I believe if I mentally do the math, I think it's 3,000, but I'm just going to do it anyway. 15 times 20 times 10. Yep, 3,000 inches cubed. So that's the volume of that tank. Now we're going to fill that tank with these cups of water. So let's get the volume of the cup of water so we know every time we pour one in, how much water we're pouring in. Now, the radius is 2, so 2 squared times pi, or times 5 times pi. Now, here's the thing. I do not want to round this number, because if I round it, then the answer that I'm going to get is going to be off slightly. So instead of rounding it, I'm going to actually write out the whole thing. 50.2654824 even goes on further, but that would be plenty. Now, every time I pour one of those in, that's how much water goes into this tank. So how many cups is it going to take? Take 3,000, divide it by that number. 50.2654824 Okay, I'm going to take my calculator. Go ahead and do that. 3,000 divided by 50.26544824 and I'm ending up with hold on a second. Let me just double check my math here at the bottom. Yeah, this number that I have at the bottom is wrong. I thought that for a second. This number down here is wrong. It's not 50.26. Let me go back and fix that. Apologize. Somebody should be here to shout me out and say, Mr. Whaley, it's not what I got. Okay, I got this 62.8318. Okay, so I'm going to divide them by 62.8318. Okay, and when I do, end up with 47.7 cups. But if I read the question carefully, what's the maximum number of full cups that can be placed in without the water overflowing? So if I was to round that up to 48 cups, well, you know what would happen? The water would overflow. So it's not 48, it's actually going to be 47. If I put in 47 cups, it will not overflow. So 47 cups it is. All right, I know that was a lot. That's it for today. Enjoy the weekend, and we'll have another video coming up next week.